second resilient talk of the year. And today's topic is on barriers and knowledge gaps for effective heat wave response. As we all know, that extreme weather conditions and events have plagued humanity since its inception, and temperature extreme encompasses heat waves and cold spells. Heat waves have become very frequent these days and intense in the past many decades. Recent scientific assessments indicate that as the global temperatures continue to increase, because of climate change, the number and intensity of extreme heat events are likely to increase in future. Also, the scientific literature has also extensively investigated the effects of heat waves. That is already a heterogeneous body of reviews in this particular subject matter. So let us see how this webinar entails to understanding the impact of extreme summer heat that may be exacerbated by increases in the humidity. So we welcome you all for this webinar, and today we have four speakers: Dr. KJ Ramesh, who is the former Director General of IMD, Professor Upasna Sharma from IIT Delhi, and Dr. Shivangi Somvanshi, who is a geospatial consultant. And I would also like to thank Dr. Mukta Girdhar, who at the last minute agreed to become the moderator for this particular session today. So Dr. Mukta Girdhar is the senior consultant at Delhi Disaster Management Authority. So I welcome you all, and now I hand over the floor to Dr. Mukta Girdhar. Over to you, Dr. Mukta.
Thank you so much, Swati, and giving me this wonderful opportunity. With this, I would like to invite Dr. KJ Ramesh. He is a former Technical Commission for Air Quality Management, National Capital Region, Delhi, India. Former Director General of Meteorology, India, Meteorological Department, Government of India, Senior Advisor. Rhymes since April 2021. An adjunct professor, National Institute of Advanced Studies, Bangalore, India. He is doctorate from IIT Delhi and specializes in numerical weather prediction and monsoon dynamics. He has got over 50 reviewed research publications to the credit and many awards and distinction to his credit in the domain of meteorology, climate change and environment. So now floor is over to you, Dr. Ramesh.
Because of global warming, what is happening is year on year, month after month, we are breaking the records of the past. Same is true with March 2024 was warmest ever March, and April was also warmest ever April. So these temperature increases will continue, and they will have different scales of warming with the global warming of 1 degree, 2 degree, 1.5 degree, like that. And we'll see how India is changing and responding to the global impacts, because global is one factor, greenhouse gases, and our own land use, land cover development, um, planning, and how we manage our resources. So we have heat wave is not new to us. For India, if you see April, May, June, so we it's a hot weather season. So 37, 40, and many times occasionally above 40 up to 45 have been experienced in India, but not to this scale of change that has happened. And then uh, our resilience to heat wave is much better compared to others, because we are been seeing hot weather conditions from the beginning, but the dimension and scale, intensity, spread of heat waves have changed. So that's how we have been working on developing heat wave action plans and stakeholder partnership. And to plan everything, you should have a good early warning system for heat waves. So that's what I'll try to focus more on, and how we have built a handholding with the stakeholders, and what are the gaps. See, it is a science. So always there will be something which has to be improved. So over the years, compared to 10 years before and now, in different time scales, we can predict the heat wave with more skill and probability, and we can quantify, identify the hottest parts, etc., etc. So there are always gaps. We will talk in between how. See here, early warning system is fairly matured for heat waves, so that I will explain. And effective heat wave response is not same every year. So we have guidelines, we have consultations, we have heat wave action plans, but year to year response to a heat wave warning is not same in different states. That's where we have to become more structured and organized, and systematic. It has to become a part of the standard operation procedure of the system. Cyclones, we have best early warning system, best response system, best emergency response planning, and all that actions required for cyclone we have put in place all across the coastal states of India. But for other things, we are building. Heat waves are better compared to other responses to thunderstorms or floods. So heat wave response system is much better. How it has become better, that also we'll discuss partly. See, basically, when soil is wet, so net solar radiation yellow is always there. Uh, sun will bring uh, uh, radiation to the earth's surface. That's how the during the day it warms up, night it will cool down. So when soil is wet, when moisture is there, rainfall is one reason. So you will have less of dry heat going out of the soil, and more of heat and moisture. This is, we call it latent heat, that will be going up. This quantum latent heat will be more, and sensible heat will be less. So when soil is dry, like dry soil, when dry spells are there, when dry soil is dry, notwithstanding with the April, May, June season or any season. This is true for every season. In April, May, particularly low rainfall period, rainfall will not be there. So that's how you will have radiation. This moisture will not be there, so latent heat will be less. More of dry heat will go into the atmosphere. So air closer to the soil, uh, ground, so we'll get radiation both from sun and as well as the long wave radiation from the earth also. So these are the two factors which will contribute for the warming of the atmosphere above the ground. So if you see, uh, when warmer, so you will have, this is a boundary layer we call it. So that's where the most of the interactions from the ground and the overlying atmosphere take place. When this height is higher, it is 1 kilometer roughly. So when it is higher, so you have more column of atmosphere to distribute the heat coming from the land. So if it is less, winters particularly, that's where the pollution becomes very high for us. So this PVL height will be less, it is only few hundred meters. So that's how there is no place for pollutants or heat to get distributed vertically. So, and then cloud cover will be minimal because it is a dry condition, so cloud cover will not be there. So you will have solar heating coming directly and as well as long wave radiation from the surface. So at the same time, it is a dry situation, so humidity will be less, नमी जो एटमॉस्फेयर में है. एंड इसके साथ साथ ओशन में क्या होता है साइमल्टेनियसली. So when hot weather conditions are there over land, ocean also is relatively warmer, particularly the eastern part of equatorial Indian Ocean. So that has got direct correlation. Eastern Indian Ocean, sea surface temperature, the blue color. Blue color is gradually increasing, like air temperature increasing because of global warming. So ocean temperatures are also increasing gradually. So And if you correlate the land temperatures with this, so this red one is also growing. So with land temperatures increasing, at the same time, ocean temperatures are also increasing. So that is another relation. So simultaneous warming of the ocean, particularly eastern equatorial Indian Ocean, associated with the dry periods and the hot weather conditions over the land, also simultaneously happening. So if you see, this is the heat wave duration over India for a particular typical year average for long 30 40 years. If you 1961 to 2013, if you average, so heat wave duration is on and average 4 days at different point, varies from 1 day to 4 day. But we'll see how it is changing and what are the trends. So with global warming, what is happening is hot extremes are increasing, which we are seeing because shifting of the mean is there. Increase in the mean temperature is happening. So you are seeing more and more hot weather events, and then at the same time increase in the variance. So year on year variance, month to month variability, week to week anomaly, monthly anomaly, weekly anomaly, daily anomalies, they are also changing because of the global warming. So that's why we are getting one component of additional incremental addition in the extreme events. So mean is changing, variance is changing. At the same time, if you combine both mean and increase, so we are seeing manifestation of warming. This is true for all parts of the globe. It is from IPCC, so we are 6. So we are bound to see this warming manifested across the globe, whether it is India or Africa or US or Europe. So that's why we are seeing it. Everybody has to face this Arctic and Antarctic, everything. So if you see, India is vulnerable for multi hazards. So heat wave is one of it. So you have something called National Data for Emergency Management. So multi-hazard districts are identified. They are about close to 250 to 60. So each district of India is experienced by multiple hazards. Somewhere earthquake, flood, somewhere cyclone, flood, heat wave. Heat wave is common now for most of the districts. So we have a mixture of those things. So we have hazards, we have heat waves, we have thunderstorms, we have cyclones, we have floods. We are multi hazards. So we are seasonally one hazard or the other is bound to happen in different some parts of the India or the other, and we are more vulnerable because of our exposure, population density, poor housing, and low per capita incomes. Our socio-economic conditions are mostly responsible uh, for vulnerability. And exposure, outdoor activities of 50% of the population is in the open field, agriculture or construction activities or other related daily activities. Now delivery has become very important. Another exposed activity of our population, at least 10%, 15% of our youth are working in the delivery services. And urbanization, heat will increase because of reduction of agriculture areas, reduction of social forestry, urban forestry in areas. So concretization, urban heat island, there are those other things. And then climate change signals are very strong. So I don't want to spend more time on heat wave definition. So we have anything above normal maximum temperature is more than 5 degrees for successive days. We call it as heat wave period. But above 37 degrees centigrade, you start feeling stress, heat related stress physically. So with age, that stress will be more, because resilience will be less for your body. So that's how the impacts are related to discomfort at personal level. And it is a combination. Meteorologically, we take a temperature, humidity reduction, low high temperature, low moisture, winds, dry winds, and direct sunshine. And socio-economically, the kind of accommodation, kind of work you do in the open field, or um, um, tinned roofs, factories. So you get even inside, you will have more heat because of the asbestos roof, or tin roof will add additional heating. And clothing, of course, is important. So then your fitness is acclimatization, we talked about it. So then frequency and intensity of heat wave, how they are changing, and is there any geographical shift or spread, and duration, and what is it in projections. So if you see frequency and intensity, we have been seeing year on year, we have hot weather days. So heat wave will be invariably there in every year, some part of the India or the other. But severe heat wave days are increasing. This is more important. So severe heat wave days are increasing. So base temperature itself, mean will also increase, and then over that you will have heat wave. So that's why we are seeing above 45, above 42. Mean itself, weekly mean itself is increasing. We have seen mean is increasing, variance is increasing. So when mean increases, and over and above the 5 degrees increase, this is what severe heat wave will happen. And warm days are increasing for different periods. So that is very clear in recent decade, 86 to 2015, even earlier, with a lot of uh, uh, confidence. This data is showing increasing trend is with confidence. So not only in India, in neighboring, if you see Sri Lanka, that is increasing. Nepal, it is increasing. So coming back to March, April, May, June. So these are the 4 months period. June, Peninsula will not have heat wave because monsoon will come, but most of North India, particularly Northwest India, will experience till the end of June, till the monsoon comes. So you can see average frequency of heat waves uh, from 61 to 2020. If you see, so earlier 4 days we have seen global average. Now we are going up to 6 to 8, from 4 to 6 to 8, if you uh, come to recent years. So globally 4 days, but if you come to India, it is already in recent 6 decades. If you see, it is already 6 to 8 days. And their trend, many areas it is increasing. Red triangles and filled triangles, they are all the significant increase and increasing trend. These are consistent trends. Blue areas where heat waves are decreasing, significantly decreasing. Some of the areas, they are marginally decreasing. So many areas we are seeing increasing trend of heat waves. So if you plot it differently in a uh, total number of days. So this is what we discussed. It is more. This is an updated figure. Uh, this is the that is for March to June. This is also for March to June. So this is station-wise increase. So this is the correct figure. Average earlier one color was not correct. So this is the correct one. So you are seeing several places we have gone up to 8 days. So that's what I was wondering where it has gone. So, 4 days to 8 days, the duration of heat wave conditions have increased compared to global average. And then this is what the maximum duration of heat waves. This is average heat waves. So that's how the difference is. So this is maximum duration of heat wave in different parts of the. That was the average, and this is the maximum duration of heat wave. So this is a maximum duration of heat wave is also has geographical change. So that is another factor. And severe heat wave conditions, if you see, so there again, over the hot heat wave, so there will be spells of severe heat wave. So that will be less, 3 days, 4 days. When heat wave is already there, over and above, it's an anomaly. So, and it has got linked to El Nino and La Nina also. So El Nino years, as we have seen, more spatial extent of heat waves, La Nina years, it will be less. More or less, the areas of heat waves or severe heat waves, they are same. But the spread of aerial spread of heat waves will change from El Nino global factors also. Apart from greenhouse gases, global warming, that is there throughout the year. But whereas when El Nino and other global temperature drivers are there, so that also has a link. So you can see in terms of numbers, um, that was only color coded. Color coded has a range. So if you see different actual numbers, you can clearly see these are the areas. Some of the areas 19 days in Punjab, 17 days in East UP, and 16 days in Jharkhand. So 19 days in Rajasthan, 24 days if you go to Sri Nagar. So like that, aerially we have heat waves, and similarly severe heat wave days are also like this if you calculate the numbers. So,
Kindly wind up quickly.
so most importantly, it changes with the number, it changes days with season and
Ki-
degree. So in
Excuse me, sir.
three,
Excuse me, sir. Kindly wind up little. Yeah.
tell me.
Kindly wind up.
Yeah, yeah, I'll
Yeah.
do that. So these are a lot of spatial pictures are there, and then we have seen trends, and more importantly, the April 2022, if you see number of uh, duration of heat wave from March 22 to April 22, it varies from month to month. We are seeing not only in India, several parts of Pakistan, Sri Lanka, we have seen. So with 1.5 degree warming, 2 degree warming, you will see the increase of warming spreads all over the world. And similarly, heat and humidity related impacts on human health also increases with temperature. So projections for India are on the increase in the decades of 2050, 2060, 2080, 2090. So these are some of the factors, and we have heat wave action plans developed for the country. And what we have seen is significantly decrease. Heat color coded early warnings are started and they are verified at district level. And heat wave action plan started from 2015 in India, and from 2015 to now, the mortalities have decreased because of the coordination with NDMA, with the state disaster management authorities, and associated heat wave action plans and preparedness meetings have reduced the heat wave mortalities, and that is not consistent. So to ensure minimum deaths, we have to work on strictly implementing response actions in the heat wave action plans of different states. Thank you very much.
Thank you so much, sir. And we'll take questions end of the three speakers. And now I would like to invite our next speaker, and the next speaker is Professor Upasna Sharma. Professor Upasna Sharma is an associate professor and associate head at the School of Public Policy. IIT Delhi. Her research interest lies at the intersection of adoption to climate change and risk reduction related to natural hazards and variability. In her recent work, she has engaged in understanding vulnerability and adoption to heat wave in the Indian context. In her past work, she has asked questions related to the role of information and communication technology in enhancing ability to respond to climate risk. She has investigated questions on adaptive capacity in the context of extreme weather events like cyclones and public response to hazard early warnings. She has studied science policy interactions and the effect of institutional features on landslide risk management system. We welcome you, ma'am, and floor is over to you.
Thank you. Thank you so much, Dr. Mukta. And it was wonderful hearing you, Dr. Ramesh. I think you gave us the state of art, le the leading research in this area. Thank you so much. I'll be speaking from a very different perspective today. So it is more about, lived experiences of the most vulnerable groups. So basically, this is we did a very short project with the which was funded by Australia India Institute. It was called the Unnati round for them, and we had partnered with Curtin University in Perth, and we had done this case study in Delhi, and the Curtin people had done it in Perth. We so I'm not going to be presenting the comparative perspective between Delhi and Perth. What I'm going to present today is, keeping to the title of the theme of the talk series, that today we should be talking about what are the barriers and knowledge gaps with respect to effective response to heat waves. So, what I'm going to present today is some of the learnings from the Delhi case study in terms of what are the barriers and knowledge gaps in effective response to heat waves. Um, so this we had done this project together, my colleague Dr. Anshu Ogra and myself,
Ma'am,
and we
can I
had
interrupt for a
yes,
minute?
yes, yes, yes.
Can you just put it on the slide board?
Ah, sure, of course. I'm sorry, I forgot
Yes.
that. Of course, I'll just do that. Yes, yes.
Thank you. Thank you.
Um, is it on the slide mode now? Is it
Yes,
visible
ma'am.
in this? Okay, okay.
Yes, yes.
And we had contributions from some of our students and research associates. So, so I'll continue with this. So I think what is interesting is that heat waves is now beginning to account for highest increase in mortality rate of mortality, not the exact numbers, but rate of mortality according to certain studies. And it between 2000 and 2020, it actually claimed deaths of over 16,000 Indians. Despite that's the figure that is being quoted, despite the fact that attributing some of the mortality. So probably it's underreported because attributing some of the mortality to heat is not always clear in a medical sense. We started looking at what was emerging in the news media about Delhi heat waves, and what we noticed was that health impacts were highlighted, and mortality and morbidity were highlighted. But it's difficult to establish this correlation between heat waves and whether the mortality was really caused because of the heat wave. So very often there's some underreporting as well. Um, we also found that there is limited or no coverage of intersecting inequalities. I'll come to what is intersecting inequalities in a little bit of time, down few slides. And also there is the entire focus is really mortality and health impacts. There is no focus on economic and non-economic losses that actually many of the vulnerable groups face because of the heat wave conditions. So very quickly, what was the project doing? We were basically, because it was a short project, we our scope was not very ambitious, but what we did was we tried to investigate the impacts on the most vulnerable groups. What impacts do they experience? Examining actions most vulnerable groups undertake to combat the heat impacts, and exposing the barriers that they encounter when they try to mobilize and afford protective measures. To specifically highlight separately. So what did we do? We had two things. We did two things. One, we did semi-structured interviews with individuals and institutions that are engaged in response to heat waves in some capacity or the other. And n- and second, we did group discussions with the vulnerable groups or groups that are at high risk to heat impacts. So we asked a whole set of questions around impacts on adaptation, barriers, energy poverty, and what does that mean? What are the losses? What are the strategies people face? There's a whole set of questions we asked. Then after that, this is just to give you a sense of, the this was done by IMD. This is not done by me. And this was basically what does what do temperatures look across land surface temperatures look like across Delhi. And this is from 2019, so it's a bit dated. This map might be redder, who knows? But I don't have access to the latest one. But this you can see that there are many areas where actually temperature values are pretty high, the ones in uh, dark red. So there is spatial variability in how it's not just a mean, but there is spatial variability in how heat is experienced in different parts of a city. Then one second. So we interviewed people from the government. We interviewed members of IMD, National Disaster Management Authority, Delhi Disaster Management Authority, Delhi Transport Corporation, Municipal Corporation of Delhi, and Delhi Urban Shelter Improvement Board, because we felt that each of these were in some way or the other involved in response to, heat. And then we also interviewed some non-governmental organizations and think tanks like the All India Disaster Mitigation Institute, IRADE, IED, just to give you a few snapshots of, our FGD sites and what we were doing there. So we went to Rain Baseras, and um, in addition to uh, uh, the certain informal settlements where heat wave impacts, where we expect the vulnerable people to be actually located to in a large extent. Um, so So we asked questions around, as I mentioned, on what impacts they experience, what do they do about it, what are their strategies, and what are their suggestions for improvement and so on. Now there are a lot of different kinds of findings. I'm not going to be focusing on every kind of finding here. What I'm going to be focusing on is certain. So we are still analyzing our data, and we are beginning to write a report and paper. Hopefully that will be out in public domain soon. But what are some of the salient things that emerged that I think are relevant for the theme of the talk today? So I think while there is better understanding compared to a few years ago about who are the disadvantaged groups, there's still a knowledge gap, and I'll try to explain how. So from the interviews that we had with individuals in different organizations and individuals located in those organizations who respond to heat, the interviews threw up, when we asked who are the vulnerable, who do you think are people who are most affected by heat, who are vulnerable, who don't have the capacity to really cope and adapt. So it turned out daily wage workers as coolies, construction workers, rickshaw driver, hawkers, traffic police, homeless, beggars, migrants, urban poor, school children, elderly people, cancer patients, and so on. In a commonsensical way, we are even aware of it, right? From FGDs, we got additional categories like disabled, abandoned people, migrants, beggars, and unemployed, and women of all age groups, who are in those rain baseras and other informal settings. Then we looked at the Delhi draft heat action plan. It was a draft heat action plan we were looking at the time. And we noticed that many of these categories are mentioned here, like infant and children, senior citizens, women, outdoor workers, traffic police. But let me take the example of outdoor workers. Now, outdoor workers are of many kinds, right? So, I think what the next, so I mean, it's a great thing that heat action plans have emerged in the country across different cities of different qualities, of different effectiveness, right? But I think for many action plans, what the next step perhaps should be to actually disaggregate each of these categories further. So, because the strategies for communication and any sort of, uh, in a way, response in terms of providing shelter or providing cooling spaces or providing ORS solutions or providing any sort of measures which will actually help them uh, cope with the heat wave at that point in time better, to avoid mortality, to avoid morbidity. uh, the strategies for each of these categories is going to be not the same, right? You will have to employ different kind of communication strategies, different points where you can actually give relief measures and so on. So I think it's important to start disaggregating and start thinking in terms of uh, where where these people are located and what communication strategies and relief measures might work. So for coolies, for construction workers, for rickshaw drivers, hawkers, just saying a, one big category called outdoor workers is perhaps not as useful as it would be if we actually look at specific categories. Again, among children, it is school children. Among women, women of all age groups, women, as the heat action plan says, which women? It's not every woman. It's basically, typically maids who are working in kitchens, women who are working in indoor environments are not able to go out, women who, we even heard of cases like women have to actually not refrain from going to the bathroom to relieve themselves because it's a shared bathroom, and they don't want to use it very frequently, so they will take in less water, and because they will take in less water, they get dehydrated more, so there is heat exhaustion. So certain, even among women, categories of women, and then how are you going to reach them in terms of communication, right? So I think that is one important, because each of these categories, their vulnerabilities are, they manifest in slightly different ways, and therefore different kinds of strategies might be needed. So that is one thing. So one can talk about each of these categories separately, but I think in interest of time, I will restrict to what I've said. Another thing which is at the moment completely missing in all heat wave action plans across the country, and is a direction where one should maybe start thinking about, is intersecting inequalities. Now, what does that really mean? Intersecting inequalities are basically when the same person is actually afflicted by multiple disadvantageous positions. So you're not just a woman, you're a single mother, maybe even disabled and abandoned by your family. So your ability to cope is perhaps even lesser compared to a person who does not have so many different kinds of inequalities intersecting at the same point, right? So senior citizens with, not all senior citizens, but particularly those with chronic health conditions and no economic support, right? So I think the idea of intersecting inequalities is important. I think it will take some time before it percolates into policy documents and action. But I think it's important to start talking about it and thinking about it, because there are certain categories of people where the inequalities intersect in a very prominent way, where, which is the lowest hanging fruit in terms of giving response and relief measures, where it will be most effective and will actually reduce mortality and morbidity. But it's not just mortality and morbidity. There are other kinds of impacts that were felt, which were like, I'll just come to that in the next slide. So, so other kinds of impacts which were felt were like, so loss of life, income if you're not able to go out and work because you're unwell. That is again a well-known thing. But when it intersects with other kinds of inequalities, it actually leads to a loss of dignity. Yeah. So loss of dignity sometimes because you are having to you don't have access to certain kinds of facilities and resources, and you're not able to mm, actually respond in a dignified manner. So many economic and non-economic losses affect people and their confidence and their vulnerabilities much more, right? Now, what kind of actions did we find that these people were taking anyway, right? So what we learned from interviews and our FGTs was that many people tried to use outdoor shaded spaces like parks. Again, these seem commonsensical, but how do we weave it into something which will be policy actionable, right? Refuge areas like temple, people try to, rehydrate themselves through certain kinds of drinks. I'm sorry, my phone is then arrangements at home for sprinkling water on floor. They try to use desert coolers, try to change clothing material, which is not so easy because cotton material has actually become more expensive and synthetic material is available, and wearing synthetic in the heat is very difficult. Using toilets for even using toilets for shade, wrapping drenched wet clothes at night to sleep, staying indoors, and so on, right? So these kind of common actions we are all familiar with these kind of actions. Now, what were some of the barriers that we got from interviews and FGDs that these people face in being able to take actions? So, women particularly said that in certain informal settlements that they wanted to access cool spaces like parks and shaded trees in the evenings or mornings, but they found safety a big issue. So that's a more bigger governance challenge to which it has to be linked, right? So if if women are not feeling safe going in a park to get some fresh air and in the morning or evening and get some shade, then that's a serious disadvantage she's facing. And access to resources like water, cool spaces. Another very interesting thing was this lack of perception of heat as a risk and insensitivity towards groups vulnerable to heat waves. So there is a general perception that yeah, India is a hot country. We do face hot days, we do face heat waves, and we cope, we manage, right? That is a general perception we noticed among many interviewees and also in the FGDs. But as Dr. Ramesh showed, that the number of heat wave days and the intensity of heat wave days are likely to increase under different kinds of climate change scenarios. So, and places which have not been typically used to heat waves or not the duration and the length of heat waves that are expected in the future, for them, for many of them, they don't know the traditional coping strategies. So they are in a way very differentially vulnerable to the risk of heat waves, and this is not understood well by many segments of the population at large. And I think a serious risk communication problem is a risk communication program needs to be developed there. More recently, particularly this year, in the context of elections, I'm seeing that in certain states that's happening. In certain quarters, it's happening that people are actually giving out risk communication on how to protect yourself from a heat wave when you go out on a hot day to vote, which is actually great, right? But this needs to be done at scale and in a much more urgent fashion, right? So, so what we noticed from the heat action plan, what were some of the suggest strategies that they were suggesting, because they were suggesting whatever NDMA guidelines were suggesting. And this we are actually analyzing some of our data right now. Basically, we are overlaying the case studies from this. So we are identifying our intersecting inequalities cases. And we want to overlay with the actions from the heat action plan to identify barriers that certain categories of people may face in following the prescribed actions, right? Because unless we understand what are the barriers, even the policy maker or the people responsible for response, they do not know exactly what action to. They are already doing a lot, but maybe they can do better in terms of targeted action. So this is a part of analysis which is ongoing. Um, and so again, what were again some of the barriers? So safety. So this is a little bit of a repetition, but identifying cooling centers and barriers and access to cooling centers is important, and certainly a big barrier for people from lower socioeconomic strata, right? In the planning and governance part, what we found was that there is a need for more interdepartmental conversations, right? Also, for example, the heat action plan and the summer action plan. The Delhi Gel Board comes out with its summer action plan, irrespective of heat waves, even when heat waves are not were not being talked about, because they have to plan for water. In the summer, the water requirement increases and the water quantity decreases, right? But there is no conversation between the two plans even, right? So I think it's easy to say that you bring in these conversations. The more difficult and the researchable aspect is, how do you actually bring about this coordination, right? It's not an easy question to answer, and I think more research and more thinking needs to go there. More conversation with different kinds of policymakers need to go there, and what are the barriers they face in actually coordinating with different departments, right? So I like to summarize some of the challenges that are there. So the first one, as I said, there is limited understanding of vulnerability in policy planning, right? So even the so many very few heat action plans have gotten done their own vulnerability assessment within the city, because there aren't many vulnerability assessments to heat waves existing in literature. Some are there, but they have their own limitations. So one needs to introduce the idea of differential vulnerability and intersecting inequalities in the planning process, and that one needs to actually create and generate data on where are these vulnerable people and located, and how are they vulnerable. Then the second is this narrative of heat wave risk is internalized. So you need, people are, as I mentioned, they already have this perception to we though have been managing heat forever, but things are going to change in the future, and newer places and newer kinds of people are going to get affected. So risk communication strategies need to be developed, and risk communication, not just content of what is to be communicated, and how are you going to reach the most vulnerable people. Again, there is a lot of research needed here. There is existing research on risk communication. This is quite mature field, and it's just not been applied. It's not been applied enough in the heat wave space, and that needs to be done. Another very important thing is we have not yet identified earmarked resources for heat waves. So even rain baseras are shelters for protection for cold waves, not for heat waves. It's just that some NGOs have provided some coolers there, so they're managing. But there's no standardized plan. There is no budgetary resources earmarked for heat wave resources, and without that, I think it's all talk and not much action, because how much you can do without resources. I think more research is needed on attribution of mortality and morbidity to heat. And there is a scale discordance, basically, between heat wave experience and heat wave planning, right? This is visible in the heat wave action plans if one studies them more carefully across different cities, and that needs to be addressed, and it will get addressed as newer versions of heat wave plans come in, as more researchers actually engage with those heat wave plans and write about it. But we as researchers also are very limited in the way we communicate our findings. We tend to publish our papers in big journals, but not write for the lay audience and the policymaker, so that they can understand the findings in a more digestible manner. So that is something that is a lacuna on our part, and we need to create mechanisms to address that. And of course, as I already mentioned, this is a hard and a tough question, interdepartmental coordination. Of course, that is a big area of research, I would say. I would like to stop here, and I would be very happy to have questions whenever Muktaji thinks is the right time. And thank you so much.
Thank you so much. Some even I am agree with some of the issue which you have discussed, but yes, there are some limitations, and we have to work within the limitations. So the next. Thank you so much for your wonderful presentation, and now I would like to invite our next speaker, and the next speaker is Dr. Shivangi Sombanshi. Dr. Shivangi Somvanshi is a professional with diverse experience and reputation for success in the field of geospatial technologies. She is doctorate in geoinformatics and remote sensing and a thought leader in the field of geospatial application research and governance framework. She is a seasoned geospatial consultant with the passion of harnessing the power of spatial data to derive informed decision making. Her professional expertise includes working with cross sectoral and interdisciplinary stakeholders across technology, academia, and government for providing geospatial based solutions for various use cases. So now, floor is over to you.
Thank you so much, Dr. Mukta. Um, Thank you to all the organizers and thank you to all the previous speakers also for setting the context so well. Before I start, I just want to confirm whether my slides are visible properly or not.
Yes, yes.
Put it on
In
the
a
slide
slideshow,
mode.
okay, I am in a slideshow mode, but can
Okay, you just go ahead, I think. I know you're managing it from so
yes.
far.
But again, there is an issue. I am not able to see my slides moving. Let me try once again.
If you have a problem, Shivangi, you can just email me quickly. I can, it's possible.
Yes, that can also be done. Just give me a minute.
In the meantime, we'll take a couple of questions, Mukta.
Sure.
Yeah. So now, can I request audience to, if you have any question, you can talk to Dr. Ramesh and Professor Upasna.
You may raise your hands and we can unmute yourself and ask the questions.
So I have a question to Professor Upasna. As she said that there is two plans. One is Delhi heat action plan, and other one is summer action plan. And just I want to add on, there is another one plan that is environment action plan. If you go on the objective, the three objectives are same. So somehow the DJP, they are working for the heat before the heat action plan so long. For example, Delhi Fire Service, they are also working, they are also equipped before heat seasons come. But I think this is the new concept for heat action plan. So things we are incorporating inside, and how to integrate these plans is a big question. If you have any solution, you can suggest.
Yeah, no, Dr. Mukta, actually, I don't have solutions. That is what we should be finding. So
Yeah.
I completely understand, so each of these departments are overstretched with their existing responsibilities, and now the burden of coordination with other departments. So that there is no easy solution actually. So it's a very slow and a gradual process where you need to think about governance a little differently from top down. It percolates from top down, and so you one needs to start creating mechanisms or platforms where different departments actually come together and actually, so maybe a little, maybe, do a workshop kind of a format for different departments to come together and talk about their plans for the summer before the summer begins. So maybe sometime in February. And
Yeah.
how can one department leverage over other departments' existing resources or existing capabilities, or how can, so, and it will be an iterative process. So this has to be done. So certain new things will have to be institutionalized.
Yeah.
So, but as I said, it's not, somebody at the top will have to take that lead and say, okay, all these departments are responsible for it. You get together before the summer and talk to each other. This is your agenda. This is your mandate. The talking to each other, of course, will have to happen. So it will improve over a period of time. But
Yeah.
that has to begin first.
Correct.
Thank you. There is no easy answer to this. Let
There
me
is
put
no
it like,
easy answer and not easy way out.
no, 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 no easy way out, but it has to be done if you one has
It
to be
has to be
effective.
done. It has to be done.
Right, right.
Yeah. So I think
Okay. So thank you. My topic is primarily technology related because I'm a geotechnocrat, and how the technologies like geospatial technologies and other allied technologies can help, or you can say, the facilitate the effective heat wave mitigation. And I'll be covering small the challenges which were mentioned by my previous speakers, that how those challenges can be overcome, like identification of the right vulnerability areas, or the early warning or the real time warning can be done using the remote sensing and the other allied technologies. So the recent research, so when we are saying urban heat islands, there is a very close relationship of urban heat islands and the heat waves. The recent research have shown that the urban heat island effects can increase the frequency and the duration of extreme heat events, as it can extend the duration of hot conditions and reduce the time window of the relief and high heat exposures. And as most of the population in India, they are actually staying in urban areas. So these zones, these urban heat islands, which are primarily located in urban areas, they are more vulnerable, and the people who are staying in these islands or in these areas are more vulnerable, and they are actually more exposed to the threats of the heat waves. So the proper understanding of urban heat island effects, its occurrence, and continuous monitoring in the real time is actually an important factor for effective heat wave response. Next slide, please. So, what you mean by urban heat islands? What are urban heat islands? So, they are actually the urban areas which experience higher temperature than the outlying areas, the suburban regions. And the difference in the temperature is what constitutes this urban heat islands. The difference in temperature actually has to do with there are many parameters which are actually contributing to this, and it's primarily the change in the radiative and the thermal properties of the impervious surfaces, like the roads, the construction. So all these materials which are used, they absorb more of the heat energy. So, or you can say that heat absorbing characteristics of the building and the pavements. So these kind of structures, they lead into the difference in this kind of temperature, and the temperatures vary within cities during to the spatial distribution of the land use, the water, the soil, the vegetation, or the impervious surface which is present, and that actually leads to the formation of these urban heat islands, where the temperature of that specific zone is higher than that of the suburban regions or the nearby regions. Next slide, please. Now, the causes. What are the prime causes? As I told, there are many factors. So, prime causes number one is the albedo and the infrastructure. So, the type of material you are using, be it asphalt, concrete, or the bricks, they rather than reflecting, they absorb the sun's heat, and they're causing the temperature, surface temperature, and the air temperature to rise due to the thermal storage capacity. Then, second is reduced vegetation in the urban areas. So, minimizes this number of vegetation cover, the reduced vegetation cover, it minimizes the natural cooling effect, or you can say the shading and the evapotranspiration from soil and the vegetation. Third is anthropogenic heat. So, like vehicles, air conditioning units, buildings, and industrial facilities, they all emit heat into the urban environment. Then urban geometry. So tall buildings, they act as an obstacle and reduce the wind flow, which would bring cooling effect. Then weather. So calm and the clear weather conditions, they maximize the amount of solar energy reaching urban surface. Um, Conversely, strong winds and the cloud cover, they suppress the heat island formation. Then last is the geography. So large water bodies, they can moderate the temperature, while nearby mountains, they can block the wind or create wind paths that pass through the city. So these are some of the major, you can say, the parameters which are actually contributing towards the formation of urban heat islands. Next slide, please. Now, there are actually two types of urban heat islands. So, urban heat island can form during day as well as during night, in small and the large cities, and in any season, be it winter, be it summer. So, there are two types of urban heat island. One is surface urban heat island, atmospheric, and the other one is atmospheric, that is air, urban heat islands. So surface temperatures vary more than that of the temperatures during the day, but uh, both these temperatures, surface and the air, are almost similar during the night. So you can see, as here in this picture, the variation of the surface heat temperature during the day is more, between the difference between the air and the surface heat temperature during the day is more compared to that during the night. Next slide, please. Okay. So here you can see surface urban heat island, the difference through this satellite image I'm trying to show. On left, you can see the surface heat island in case of urban, suburban area, where on the right, you can see the surface heat island in an urban area, and both are during the daytime primarily. So surface urban heat islands, they represents the radiative temperature difference between impervious and the natural surface. And surface heat islands, they tend to be more intense during the day when the sun is shining. And magnitude varies with seasons, but it is typically largest in the summers. So these surface urban heat islands are primarily measured by remote sensing in thermal infrared region for electromagnetic spectrum. So, as the previous speaker, Professor Upasna, was showing one map of land surface temperature for 2019, and she said that she is not having the access to the latest data. So, I just want to bring to your notice that land surface temperature is being measured by EcoStress satellite of NASA on daily basis. And that kind of information is available on daily basis. You can even access that data of yesterday as well. Next slide, please. Now, monitoring urban heat islands, how you monitor. So primarily, we are using satellite remote sensing. So one of the parameter of identifying the urban heat island is land surface temperature, of course. So satellite thermal remote sensing, they measure the this land surface temperature, which is again correlated with other socioeconomic parameters, and we calculate the urban heat island vulnerability of an area. And believe me, that can be done on daily basis. So that frequent the intensity and the frequency can be. So satellite thermal remote sensing, they measures SUHI, that is the surface urban heat island, and provide consistent and repeatable observations of the Earth's surface. And remote sensing is beneficial in this case. In when we talk about the IMD stations in a city, in a specific city, for example, there are only two meteorological stations in a city, right? And they are capturing the air temperature, they're capturing the humidity and all the parameters, but only at that two specific locations. When we talk about land surface temperature or urban heat island, this is a very dynamic process and it keeps on changing. So based on those two stations, even if you're interpolating, the accuracy of calculation of that land surface temperature is not that accurate, or heat wave is not that accurate. Here, the spatial variation, what the satellite thermal remote sensing is providing, is very beneficial. So you can get that variation, dynamic variation, very easily using remote sensing. So remote sensing offers the ability to study the urban thermal environment at various spatial, from local to global, and various temporal from daily to seasonal to interannual scales. So everything is available. It's just about how you're using it more efficiently, depending upon your necessity or your need. Then surface urban heat islands represents the difference of the land surface temperature in an urban area and in a non-urban area. And through that, you can see this map. This is a difference map of a land surface temperature of an urban and of a non-urban area in US. And you can see the hotspots. You can actually identify the hotspots where the temperature difference is very high. So within that, primarily most of them lie into an urban area only, and usually measured using the satellite data. So the intensity of the heat island is actually the simplest you can say quantitative indicator of the thermal modifications imposed by the urban relative to non-urban areas. Next slide, please. I think you skipped one slide. Yeah. So why are urban heat islands a problem? Number one, increased risk to heat-related mortality and morbidity, as Professor Pasma also mentioned. Increased energy consumptions. So, fine, those who are not able, who are not, they're below the poverty line, they are exposed to these heat-related issues, and the deaths are taking place. But those who are well, they're rich, they're using ample amount of ACs, like they are, every room is having AC, so more of the energy consumption. So as per G20, India is focusing a lot on energy, um, the energy policies and energy strategies. And one of the things which should contribute towards this energy strategy is how you can reduce this energy consumption by having a right time early warning alert of urban heat islands and a proper mitigation strategies aligned to it. Then elevated emissions of air pollutants and the greenhouse gases is also rising temperature will give a boost to hell lot of pollutants and the other gases. And of course, it is affecting the water quality. Next slide, please. Yeah. So as I was telling that the image which you can see just behind uh, this heading, this is actually the image which I came across from NASA's EcoStress temperature data. So this NASA EcoStress, they have been measuring these temperatures from space at the highest of the resolution, spatial and the temporal resolution. And the acquired data can be used for monitoring diurnal dynamics of surface urban heat islands for urban agglomerations. So here you can see they have covered the Delhi part. Like I'll just took the part which is covering the Delhi and the nearby areas, and you can see the hotspots. And the best property of this particular data is this is a nighttime data, where the other satellite images which the people were using previously was Landsat or MODIS. You can only get the daytime data. You can only understand the dynamics of the temperature during daytime. But by using this NASA EcoStress data, you can even check the heat dynamics during the night time. So next slide. I would like to cover some of the benefits and the limitations of the remote sensing, as I just covered. So when we talk about the benefits of the remote sensing or this technology for identification of urban heat islands, so number first is the continuous and the spatial coverage compared to that of in situ data, as I just mentioned. So in situ data, specifically the monitoring stations which we are using in India. So the coverage of this satellite data is more continuous, and variability has been covered. It provides data where no systematic in situ measurements are available and augments where they have. Then simultaneous observation of LST, surface emissivity, land cover, and various from various satellites. One which I just told you, which is very recent, you'll be able to get the data of EcoStress from 2018 onwards. However, there are many satellites like from Landsat. You can check the temperature data after every 15 days. Then MODIS, VIIRS, AVHRR. So these are all the satellite data from where you can get the mentioned parameters very easily in a very continuous manner. Then global coverage can be done, consistent data coverage from many satellite data. And availability of the open source data. Then again, these all data is open, freely available. Anybody can download from anywhere and can use it. Next slide, please. So, however, there are many benefits of satellite remote sensing, but there are few limitations also. So, when we say that early warning, early warning alerts, so early warning alerts in case if because eco stress is a very recent addition, but again in case there are many satellite image where the revisit period is like 12 days or 15 days. So whatever information you're getting after 12 days. So by the time you are going to get that satellite image and you'll be able to understand whatever is going to happen on ground. Okay, fine. So, like there will be several deaths because of the late information which is coming in. So, here the remote sensing alone cannot support. So, for early warning, identifying the hotspots, the urban heat islands, and the hotspots using the satellite images, and then placing a ground-based IoT centers on those specific specific identified locations, placing the IoT sensors who can give you the real time information of the temperature and the various parameters which are used for identification of urban heat island vulnerability zones or the heat waves. So that kind of integration is required if you're talking about uh, early warning system, where remote sensing alone cannot be that beneficial. So data acquisition time of sun synchronous satellites usually do not coincide with the time of the day where the um, this urban heat island is at the maximum or the minimum. That is number one, because satellite has its own time of crossing the area. Then most widely used satellite for this is which is Landsat, um, is only providing you the information of the daytime. So ground-based IoT sensors is necessary for this. Then optical sensors cannot penetrate cloud or vegetation cover, which can lead to data gaps or a decrease in data utility. And last, it is difficult to obtain high spectral or spatial and the temporal resolution with the same instrument. Yes, until unless we are not using NASA EcoStress, fine, because that is providing you globally with the same instrument at a very high spectral and spatial temporal resolution. But for all the other satellite, yes, it is again one of the biggest challenge. Next slide. So this is my last, where I would like to sum up and say that urban heat islands are indeed an important aspect of the climate monitoring. And while urban heat islands are typically monitored using ground based instruments and satellite data, their inclusion as a space based essential climate variable (ECV) could provide a more comprehensive understanding of their dynamics and their interaction with the other climate variables for an effective heat wave response. So, identifying the UHIs will help you in knowing the most vulnerable uh, areas, which and the population which is more affected, which will be more affected, you can say, or because of this heat wave, and their effective heat wave response strategy can be developed based on this. So with this, I would like to say thank you.
Thank you so much for your wonderful talk, and it's really enhanced our knowledge, and really will incorporate your eco stress satellite images, which we were not aware about these facts, and will take help for that with you also.
Sure.
So now, floor is open for question and answer. Now, if anybody want to ask any question, please raise your hand.
Till somebody asks,
Yes.
I want to offer some comments.
Sure, sure. Please go
Okay,
ahead.
thank you. Thank you. Wonderful insights have been brought in from different dimensions. They are very useful. But year on year, when heatwave action plans started developing for different cities, first started with Ahmedabad and then slowly spreading to states and smaller towns. So particularly southern states have been, apart from Ahmedabad, southern states have been very, very responsive to the early warning alerts, saying changing the school timing so that by 1 o'clock schools will be closed before the maximum temperature time reaches between 2 to 3. Children are back at home. And then Manrega timings are restricted. It starts early morning and ends at 10 o'clock. Again, they'll start at 4 o'clock. And again, the sunlight will be there up to 7. So, um, the exposure conditions for the Manrega workers has been changed, particularly in tinned roof factories. There also production times during the daytime, particularly 11 to 4 o'clock, are shifted. More importantly, the Telangana government, which they found in 2016, was there were more uh, newborn children mortalities in different parts of Telangana in that particular 2016. So later on, one committee was formed to investigate the reason. So they found that wherever newborn children are um, deaths are reported, there they found that maternity ward was on the top floor of those hospitals. So immediately they have shifted all the maternity wards which are there in top floors to lower floors in all over the state from subsequent year. So like that, there are lesson learning has to be part of guidelines, improving the guidelines, because those local specific factors contributing to the morbidity and mortality got to be identified continuously. Simply giving guidelines and standard action plans is not enough. By seeing the experience, the gaps in your response actions or identified actions in action plans got to be updated year on year. And that should be the part of consultation across the departments of the local government to minimize the morbidities and mortalities altogether. Thank you.
So now, any question? Just I would like to add on few lines that there are so many action has been taken by the government. Each and every department they have been assigned different tasks to execute those things to reduce the heat. uh, and the different governments they are working on this line, but surely there is some gap for the integration, which I have discussed with the Professor Upasna, that there are three plans but the objectives are same, and for the same assignment has been given by the different departments. For example, that we have to go for the plantation, so every department has to work on it. CSR, for the CSR project, it has to be work on it. Then there is another, that restoration of water bodies. And there are few NGOs, they are really working good. The one of them is a Seed India. They are working for the slum people. And they are giving a small ways and means how they can reduce their heat from their houses. And these are the different techniques, I think, which we need to disseminate, and people don't know that how they can keep their roof cool with the minimum amount. So there are so many ideas which we need to disseminate, and for that really we have to conduct several workshop and conferences, and several IEC material need to be disseminated. So this is my personal view. So anybody want to put on some view, please welcome. Otherwise, I think there is no question. Swati, can you see any raised hand?
No, I can't see any raised hands. I think everybody is satisfied with the wonderful presentation made by our speakers. But I would really like to share that Dr. Shivangi, you have put up a great um, presentation out there. Especially, even I didn't know about eco stress data, which is available, and we have been working on, in the past with Lancet data, multispectral data, list how we used to calculate the surface temperatures. We've been working on the old data set, but now you have given something highlighted on something which is available and like, on a daily basis. I think the ease of work will be very effective and very productive if we use such data which is available to all of us, and that too freely. That is the best part. Acquiring the data is the biggest problem in a country like India, like especially in India. uh, you need to take so many permissions, move on, like from one department. Okay, the government has their own inhibitions of acquiring the data and using them. The researchers can't use, academics will not get it. There's so many problems around. So but yes, this definitely open source data is very good initiative. I think anybody who's in the academics research sector, you should make full utilize of those data. I've been working on a lot of open source data, but yes, this eco stress data, which I even didn't knew about it. Thank you for this information, and we'll connect more on that uh, afterwards.
Sure. Thank you, Swati. And I would like to add that even in India also, it is not that difficult now. We were having a discussion with NRSC. NRSC, they have started their nicest portal where they are actually collecting all the ECVs together and putting it the layers, even from the satellites or the missions of the other countries. Not necessarily that they are only putting the Indian remote sensing data, but
Mhm.
all the data which are available across the globe in open domain, they have put it into that portal. And now we are working towards in bringing this UHI or LST thing as one of the ECV as a part of that portal also. So so it's not that difficult now. After this new national geospatial policy, all the data is available. It's just about you need to know the right place from where you
Platform,
can
yeah.
get. Yeah.
Yeah. Thank you for that. And Professor Upasna, your presentation was also really wonderful. You gave us an insight of, uh, especially on those gaps and that those knowledge information where we don't even look upon, in the conditions, like especially on in this really this heat summer which we are facing currently right now. I think we have this alert also in the next 3 days. It's going to be really hot summer for Delhi especially. And thank you for that information. We think as a member of a society, we should take initiatives, like to how we can collaborate and we can help the help the society to improvise on those gaps along with the government. And Dr. Ramesh, your presentation was also very nice, and I didn't have a lot of insight on heat wave, frankly speaking, but I really got a great insight into the subject as well, because that's not my domain as such. Because I'm also geoinformatics background, but yes, definitely I learned a lot from your presentation. Many things from your presentation. Thank you so much for that.
So I think with this,
Wonderful.
Thank you.
thank
Thank you for giving us this platform.
yeah, and
Thank
with
you.
this,
Thank
Bye
you.
for now.
yeah, yeah.
Thank you
Thank
so
you.
much for taking your time out and being part of this webinar. Thank you so much. Thank you. So we close from here.
Guru బాగున్నావా? ఎలా ఉన్నారు?